Astronomers, rather than astronauts, are the primary individuals involved in the discovery of planets, particularly those outside our solar system known as exoplanets. This work is done from both ground-based observatories and space-based telescopes. Here's a detailed look at the methods used to find these planets. Methods of discovering planets. 1. Radial velocity Doppler spectroscopy. This method measures changes in the velocity of a star induced by the gravitational pull of an orbiting planet. As a planet orbits its star, it causes the star to move in a small orbit itself. This movement affects the light spectrum of the star, causing a Doppler shift. When the star moves towards Earth, its light is slightly blue-shifted, wavelengths become shorter, and when it moves away, the light is red-shifted, wavelengths become longer. By analyzing these shifts, astronomers can infer the presence of a planet, its mass, and its orbital period. 2. Transit photometry. This technique involves monitoring the brightness of stars to detect periodic dimming. When a planet passes directly between its star and an observer transits, it causes a small, temporary decrease in the star's brightness. By measuring the amount and duration of the dimming, astronomers can determine the planet's size and orbital period. The Kepler Space Telescope has been highly successful using this method, discovering thousands of exoplanets. 3. Direct imaging. Directly capturing images of exoplanets is challenging due to the brightness of the stars they orbit. However, with advanced techniques and instruments, astronomers can block out the star's light and capture the faint light emitted or reflected by planets. This method is useful for studying large planets far from their stars and can provide information about their atmospheres and orbits. 4. Gravitational microlensing. Gravitational microlensing occurs when a massive object, like a star, passes between an observer and a distant star, acting as a lens that magnifies the light from the background star. If the foreground star has a planet, it can cause additional, temporary brightening. This method is sensitive to planets at a wide range of distances from their stars, including those in the habitable zone. 5. Astrometry. This technique involves precise measurements of a star's position in the sky to detect slight wobbles caused by an orbiting planet. Though less commonly used due to its complexity and the requirement for extremely precise measurements, it can provide information about the planet's mass and orbit. 6. Pulsar timing. Pulsars are neutron stars that emit regular radio pulses. If a pulsar has a planet, the planet's gravitational pull will cause slight variations in the timing of the pulses. By analyzing these variations, astronomers can detect the presence of planets and measure their masses and orbits. Instruments and missions. 1. Kepler Space Telescope. Launched by NASA in 2009, Kepler used the transit method to monitor over 150,000 stars for periodic dimming. It has discovered thousands of exoplanets, significantly expanding our knowledge of planetary systems. 2. Test Transiting Exoplanet Survey Satellite. Launched in 2018, TESS continues the work of Kepler by surveying nearly the entire sky to find exoplanets around the brightest stars. It uses the transit method and aims to discover Earth-sized planets in the habitable zones of their stars. 3. HARPS High-Accuracy Radial Velocity Planet Searcher. This ground-based instrument, located in Chile, is designed for radial velocity measurements. It has been highly successful in discovering exoplanets, particularly smaller, rocky ones. 4. James Webb Space Telescope JWST. Scheduled for launch in 2021, JWST will use direct imaging and other techniques to study exoplanets' atmospheres and compositions in unprecedented detail. 5. Gaia, launched by the European Space Agency ESA in 2013, Gaia uses astrometry to create a precise 3D map of our galaxy, including the positions and motions of stars. It can detect the wobbles in stars caused by orbiting planets. Challenges and future prospects. Discovering exoplanets is a challenging endeavor due to the vast distances and the faint signals involved. However, advancements in technology and methods continue to improve our ability to find and study these distant worlds. Future missions, such as the James Webb Space Telescope and the European Space Agency's Plato mission, promise to enhance our understanding of planetary systems and the potential for life beyond Earth. In summary, through various sophisticated techniques and instruments, astronomers have been able to discover and study planets outside our solar system, greatly expanding our knowledge of the universe.
If you like this video, please subscribe to this channel and press bell icon for more informative videos.